Yep, been here. Today, I'm with my 3D printer. So this video has been a long time coming. I've actually had this box sitting around for like the better part of 2 months, and it's been killing me that I haven't had a chance to put it together yet. Inside of this box, I have a Prusa. I have a Prusa i3 3D printer. This 3D printer is pretty cool. It has a heated auto-leveling bed and has a pretty big print area. I think it's like 10 by 8 by 8 or something like that. The Prusa i3 printers are pretty popular because they're really easy to use, they're easy to assemble, and typically just have the least amount of problems. This is not actually a true Prusa i3 printer. It's a generic printer that I got on Amazon for about $380. And that's kind of expensive. But if everything goes okay in the assembly and it works as advertised, then I should be able to produce high quality prints, even in ABS, which would be comparable to prints from printers many times its cost. So I have high hopes for this guy. Now, the goal of this video isn't to walk you through every step of the assembly. There's already plenty of videos and instructions out there for how to do that. I do want to show you what it takes though to get started with 3D printing. It's probably not as bad as you think. Once I get this guy assembled, I want to use it with Octoprint, which is a software which runs on a Raspberry Pi. It facilitates some really cool things, like being able to remotely upload prints, using a camera, and being able to track the status of a print through your home automation hub. That's kind of clutch. So, without further ado, let's get to it. So, there she is, in all of her glory. All in all, the assembly really wasn't too hard. The included instructions that came with the printer on the CD were awesome, and as Chinese products tend to go, they're really easy to understand. I would be lying to you if I said everything went perfectly. I made a couple boneheaded moves, like realizing halfway through that the acrylic pieces had a piece of paper over them, and using the wrong size aluminum rod when I was assembling the Y-axis frame. But the nice thing about this printer is if you make any mistakes, it's really easy to fix. Now, I was going to include a lot of footage showing the first time I powered it up, but that's not very helpful to you guys, because I literally had no idea what I was doing. The assembly instructions were pretty good, but they didn't really tell you how to do anything after that. And so after much Googling and much contemplation and trial and error, and just frankly messing up a lot, as my printer now has the scars from, I can now tell you my system to get printing with your new printer super quick. So, here we go. The first thing you'll need to do is to level the bed with a level. You can tighten or loosen each adjustment screw in the corner of the bed until the bed is level left to right and front to back. You'll also need to level the Z-axis. To do this, place a level on the top aluminum carriage rail and manually rotate one of the Z-axis motors until it's level. Next, loosen the adjustment screws on the inductance sensor that's on the back of the extruder carriage. Push the inductance sensor all the way down until it's closest to the print bed. Then, on the print menu, select Prepare and then Auto Home. After the printer homes, you'll notice that the extruder nozzle is pretty far off the print bed. The ideal height for the extruder nozzle is about the thickness of a piece of paper, or in this case, this metal tool that I'm using. Next, I'll adjust the inductance sensor again, this time pulling it up. The approximate height the extruder nozzle needs to go down to be touching the print bed. It's important that you don't raise the inductance sensor too much. If you do, the extruder nozzle can drag across the print bed on the next home and leave a pretty bad scratch. The next thing I'll do is another auto home. I'll go to Prepare and then select Auto Home. You'll notice that this time the extruder nozzle is touching the print bed, which is too low. So, to fix that, I'll go to Prepare, Move Axis, move 0.1 millimeter, and then move Z. I'll move the extruder up until it's the perfect height off the print bed. Next, I'll adjust the inductance sensor again, pushing it down until the red LED just turns on. It's important to be precise here, because if you push it too far down, then the print nozzle will be on the print bed. Then I'll auto home again, and if we're lucky, the nozzle will end up at the perfect height. It might take a couple of tries to get this right, so if the nozzle's too high or too low, just repeat the previous steps until the nozzle's at the perfect height. The last thing you'll need to do is to verify that the extruder nozzle is at the right height in each corner of the print bed. In order to manually move the print bed or extruder, you'll need to either unplug your printer or to select Disable Motors in the print menu. Even though we leveled the bed with a level earlier, it's important to do this step and to make sure that the extruder nozzle is at the same height in each corner, making any changes as necessary. Being off by as little as a millimeter can cause prints to fail, so really take your time here. Okay, so now to the good stuff. How do you print something? The first thing you'll need is something to print. You can either design something in a modeling software like 123D Design, or you can go to a website like Thingiverse. There's tons of free stuff that you can print there, and often stuff's like really cool. One of my favorite things about 3D printers is that because the extruder can retract, it can physically jump in space, leaving a hole on the inside of your print. That means you can make things that move, like this really cool articulating fish. It just printed like this. Today, I want to see how my printer's doing, so I'm going to print this 3D boat, which is kind of a well-known test to see how calibrated your printer is. So I am going to go to Thing Files and then select 3dbenchy.stl and then download it. Next, I'll go ahead and open that STL file in Cura. The next thing you'll need to do is to select the print settings you want for your print. After some trial and error, I found that these settings tend to work the best for normal prints for me. So not super high quality, not super low quality. One of the things I like about Cura is that you can save these print parameters into a profile file. That way, it's easy to jump between printer settings. So if you want to swap out filaments or create a draft print or whatever, you don't have to remember a zillion numbers. It's super convenient. So now that we have the STL file in Cura and the print parameters dialed in, we're basically ready to print. But there's two more things I want to show you.
The first is if you go to start/end G-code. Without getting into things too much, these are basically commands that the firmware on the printer interprets before and after it prints something. After the X, Y, and Z axes home, which are these two commands here, I added the command G29. Basically what it does is it measures 9 points across the print bed, and from that it interprets a plane. So if your bed has a slope to it or isn't perfectly level, it can compensate for some of that. It's pretty cool. The other change I made is in the NG code. I added this command here, G1, Y260, F4500. What this command does is it moves the print bed all the way out towards me after it's done printing. Originally it was going all the way to the other end, which wasn't very helpful, so yeah.
For PLA, which I would totally recommend starting with, I found that just using some masking tape and putting it on the print bed works great. I haven't really had any adhesion issues at all. ABS is a little bit trickier, but I found that if you make some ABS juice, which is basically just dissolving ABS filament into some acetone, it creates this nice paste which you can paint onto the print bed, and ABS sticks to it pretty well. A lot of people like to use a glass plate with some kapton tape and some hairspray, and that tends to work pretty well. The big issue there is that the inductance sensor can't detect glass, so you either have to switch to a capacitance sensor or a more sensitive inductance sensor, but not getting into all that now.
Okay, now we're ready to print. I guess I should have mentioned this earlier, but the first time you fire up Cura, you'll need to add your printer settings to the software. The installation instructions walk you through this really easily. Anyway, assuming you've done that, you can say File Print or File Save G-code. You can take that G-code file, put it on an SD card, and then put that SD card into the side of the printer screen and print directly from your printer. Or you can plug your printer into your computer using the USB cable and then just say File Print. You'll notice that the LCD screen on your printer says bed heating. It'll first heat the print bed and then heat the extruder nozzle. After it does those two things, it'll home and then it'll start printing. Bam! I didn't really get into the installation steps in this video, but printing through Octoprint is even easier. You plug your printer into a Raspberry Pi that's running Octoprint, and then any computer or device, including your phone, can connect to Octoprint through a web browser. Once you're connected, you can upload the STL file, import your Cura print settings, view your STL files, and then, using the same Cura profile files, you can select the print parameters, start-stop G-code, and then, after that, just say slice it, which will slice it into the G-code and then upload that to the printer. It's really, really cool. Another thing I liked about Octoprint is you can manually control your printer, so if you need to move the axes around, prime the extruder, or turn your motors off, turn fans off, it's really easy to do that. There's even keyboard controls if you want to get fancy. You can also look at the print layers using the G-code viewer, even synchronizing it in real time so you know where the extruder head is. And in case you didn't see that already, you can plug a USB webcam into your Pi, and then you have a nice camera on your printer, which is totally cool for tracking your prints when you're not there. You can also create time lapses, which are crazy cool to watch. The last really cool thing I'll mention about Octoprint is that it can connect to home automation hubs. In my case, I'm using Home Assistant. You can view the camera stream in real time, and it also has sensor values for the bed temperature, nozzle temperature, and print percentage. What's really cool about this is you can automate things in your house based on what your printer's doing. So, for example, your print's done, flash your lights. That's cool.
So, yeah, that's basically it. That's all it takes to get started with 3D printing. I'm super excited to say I finally have a functional and very usable 3D printer. I gotta get back to this home automation stuff. I have some Favaro products, some Bluetooth presence detectors, a garage door opener, and oh yeah, all the stuff that was in my apartment. Plus, new devices coming later in the month, like a new Echo, and Google Home, and Ecobee 3 HVAC controller, and that fabled MQTT sensor node, which I promise is coming. It's real. Hang on. See? It's real. PIR sensor, LDR, RGB LED, and DHT22 temperature and humidity sensor. I promise I'm gonna make a video about this because I know I've had a lot of people asking, and it's coming, so hang tight. As always, thanks for checking out the channel. I'm super excited that it's continuing to grow. It's crazy to me. I am trying to get better about answering people. I know that I don't answer super quick sometimes, then you guys move on and you're like, thanks bro, and I'm like, yeah, sorry. But I'll do my best, and yeah, so stay tuned. As always, happy automating. Cheers.